So maybe on another page, I'm going to build up the whole information, but we can do this concurrently with one example here. Okay. So we consider PS equal to S6 plus 4 S5 plus 3 S4 plus 2 S3 Okay, so now we arrange 1, 4, 3, 2, and 1, 4, 3, 2, 1, 4, 4. Okay, so that is the given. So that is S6, S5. Okay, so now we're going to fill out this one. So do the exercise for this number here. That is 4. And the multiplication of the C of the two numbers is 4 times 3 minus 1 times 2. Okay, so basically this one is how much? 12, 2.5. Okay? So that is these numbers. I'm running out of space. So once you have that one, can I erase these portions and leaving the space for working on the B2 here? And B2, basically again in the similar patterns here. B2 is something in the similar pattern is denominator of this number above itself. Okay, and the same thing, the multiplication of the two numbers multiply the multiplication of the two numbers, which is on the two columns next to each other. Okay, so for this number we can do this. So now the number here will be equal to, using 2 as the denominators, multiplication of the 2 times 1 minus 3 times 4. So that one will be equal to 2 minus 12 minus 10. So this is minus 5. Oops. Oops. Sorry. For this one, we take in these denominators, and now for this case is this one multiplied with this, and this one multiplied with this one. Okay. Sorry about that one. So let me modify this. So basically, this number is again this pivot denominators, and then this number multiplied with this is 4 times 1 minus 1 times 4. So that is equal to 0. Okay. And so now we work on this one. So the same thing. So we keep working on the things. So if we want to calculate B3 here, B3 basically equal to, again, using the number above us as the pivot as the denominators. And then we always starting from here, multiplication of the two numbers going to here, and minus the multiplications of the two numbers and go to here. Okay, so for this example, so here on the 4 here, so for this number, below 4 is 4, and multiplications of the two numbers, 4 by 4, minus, so let's go to here, and minus 1, multiply here, nothing, so basically nothing is 0. If you like, you can put a 0 here, okay. So basically this number is 4. Okay.
Professor,
Yes.
I I think in your handout, the numerator will be always kn minus 1.
In my handouts, yes. I think you're right. I haven't done this before a long time. Sorry, my mistake. The denominator is always this one. Okay, so can you change it? But the numerator is the same. Okay. So for this case, it's not this, and I think this should be the pivot one, so that should be 4. Good. Okay, so now for this example, let me erase the. Have you fixed my mistake here? Basically, the pivot should be always the first one. So now, once you fix this one, let me erase the calculation. Simply put a number here. Then we will proceed to the next row. So for this case, right now we calculated is 2.5, and this is 0, and this is 4. Okay. So now we proceed to the next one, 3. So 3 again, we take away this one. So we always is working on using the top 2 columns, the top 2 rows. So let me erase the unnecessary terms here. Okay. So S3, basically we're using the top 2 rows and repeat the same patterns here. Okay. And from here you can see, basically here is divided by using this as the pivot numbers here, and divide by 2.5, and multiplications of 2.5 multiply 2, and minus 4 times 0. So that will be 5 minus 0, and this one will be equal to 2. Okay. So that is this one. Now we work on this, the number below this. So that number again divides by 2.5 here. And so for this number, basically this we're working on is the number below 0 here. So basically repeat the calculations. So multiplication of 2.5 times 4 and minus 4 times 4. Okay? Okay, so that one will be equal to 10 minus 16 and minus 6. And minus 6 divided by 2.5. Minus 6 divided by 2.5. So that is minus 12 divided by 5. And that is minus 2.4. Okay, I'm running out of space, but that's okay. Okay, so now I'm going to work on the numbers below 4. Okay, the number below 4 again, divided by 2.5 here. And then this one multiply with its neighboring is basically 0, 0. So it's basically multiply 2.5 multiply 0 minus 4 minus 0. So basically this term you expect is 0 here. Okay? So with these calculations here, and let me erase the calculation, just put the numbers under this. That'll be easier for us to look through the calculations. So we calculated is this one is 2 minus 2.4 and 0. Okay, then we proceed. And one feature of the Routh Hurwitz table is gradually you can see the number will be shrink to only single one here. We see, okay, so for this one, basically using 2 as a pivot, 2 and 2 multiply with 0 minus 2.5 and minus 2.4. Okay, and that number will give us is 3. Be good? Okay, and now for this number on the 2.4 again is 2, and so basically the two numbers here, so that is 2 times 4 and minus 0, so that is 4. Okay, and this one you can check that should be equal to 0 on the list. So basically that is the calculations. I wait for you to complete writing. I'm going to erase this row. Be good? Okay, so let me erase unnecessary zeros. So if you have done, then I can erase this row, and this one basically is 3 and 4 and 0. If 0, then we don't need to write. Okay, so now we go to S1. So the same thing, S1 is using this as a pivot. So 3 and 3 minus 2.4 and minus 2 times 4. Okay, so that one, this number is equal to minus 76 divided by 15. Okay, I think it's minus 5.06 something. Okay, but anyhow. And then the next one is 0. Okay, so let me get rid of those things. Okay, so that is a calculation. Again, we can get rid of the calculation, so that is minus 76 divided by 15, and this is 0. Okay, so for S0, basically you can double check this one should be equal to 4. Okay, so now we have built up the tables, and the table will end up at the final number that corresponding to a constant term here. Okay, so this is the majority of the calculation spent on building up the table. And now the step 2. So basically these patterns repeat the patterns of each to calculate, to build up the tables. Okay, so here let me do this one. So the step 2 is we simply looking into the first column of that is the first column. Count the number of changes in sign across the first column of the Routh table. Okay, so basically we want to look for the number of the sign change. So basically for here, for this example here, you can see across the first column of the Routh table, so from here to here, there's a no sign change. And from here to here, no sign change. And from here to here, no sign change, no sign change. From here to here is change 1. and from here to change 2 again. So for these examples, there are 2 changes in size in the first column. Okay. So what this means? The sign change of the number of the sign change is equivalent to the numbers of the poles on the right hand side. Of the complex plane. Okay, would that be good? So from here, that means for this case, it indicates there are two poles on the right hand side. Of the S-plane. So that means the 2 poles with the positive real part. So at least there's a 1 pole, the system is stable. So basically from here we can tell the system is unstable. Okay, and here the Routh Hurwitz criterion can tell us how many number of the poles on the right hand side. And we can double check. And actually, I don't have a calculation for here, but if you like, you can use the root. 1, 4, 3, 2, 1, 4, 4. You can use MATLAB and type in this one to check. Okay. So that is the simple exercise. And again, in one section of our textbook in chapter 5, and there's a very thorough introduction about the Routh Hurwitz criterion, in particular exercise in building up this table. And I'm sorry I made quite a few mistakes here today, okay? But I think the calculation pretty much, down this example, pretty much catch up the suppose we have to do it correctly, okay? Coming up on Wednesday, we're going to talk about a few exceptions, particular cases. You can see when we build up the tables, we always must divide by something, and that is the first number here. And what if this term becomes to 0? Then basically wind up we're going to divide by 0, right? And how we're going to deal with this case, we'll build up the table. And that is the case we're going to talk about on Wednesday for the particular examples there. Okay, and then I think you should be ready to proceed the next homework. Okay, not everyone, not all the problems, but waiting for the Wednesday to come, and then I will give you the whole thing.